Let's solve log base 2 of the number x plus log base 2 of the number x plus 2 equals log base 2 of the number 6x plus 1. Step 1, we want to get all the logs isolated on the left side. Any numbers will be on the right side. And then we're going to condense all those logs on the left into a single logarithm using the rules of logs. So we're going to subtract the log base 2 of 6x plus 1 from the right side over to the left side, so the right side becomes 0. Now let's condense the first two terms, the two logs. So we have log base 2 of x plus log base 2 of x plus 2. That equals a single log base 2 of the product of the numbers x times x plus 2. Bring down the minus log base 2 of 6x plus 1, bring down the equal sign and the 0. Now we're going to condense the difference between those two log base 2's that are remaining on the left side. We get a single log base 2 of the x times x plus 2 number divided by the 6x plus 1. See, this time we divided the number parts because this is the difference between the logs. In the step above, we were taking the sum of logs, and those are two separate rules. So taking the difference, as we're doing here, it's the single log of the first number divided by the second number. Bring down the equal sign and bring down the 0. Okay? Now we're ready to translate because we have our single log. So we're going to go to exponential form with base 2 with the butterfly wing. Base 2 raised to the exponent 0 equals the number x squared plus 2x when I multiply across the top over 6x plus 1 on the bottom. Okay, 2 to the 0 is just 1. So 1 equals x squared plus 2x over 6x plus 1. It's an equation with fractions. Get rid of the fractions, multiply both sides by the LCD. And that gives me 6x plus 1 on the left equals x squared plus 2x. No more fractions. Solve for x. Okay, move everything over to one side. I moved it all to the side that makes the squared dude positive, so it would be easier to work with. I can't factor that. I'm going to have to use the quadratic formula. So let's remember the quadratic formula. It's x equals negative b plus or minus the square root of b squared minus 4ac over 2 times a. Now, let's identify the a, b, and c. Okay, we've got x squared minus 4x minus 1. So it's ax squared plus bx plus c. So a is equal to 1, b is negative 4, and c is negative 1. Plug those values into the quadratic formula. Plug in the b value here in the parentheses. Yeah, I like to use parentheses to make myself not, careless. So I have the negative 4 for the b value in the first parenthesis and the second parenthesis. And then the a value 1, then the c value negative 1, and then the a value 1 on the bottom. Now simplify. It'll take a little work to get 4 plus or minus the square root of 20 over 2. Now we have to simplify the radical. We ask ourselves, this is a square root. Is there a perfect square factor embedded in the 20, in the radicand 20? And the answer is yes. There's a 4 in there, and 4 is a perfect square. So we can bust apart the radical portion. X equals 4 plus or minus the square root of 4 times the square root of 5 over 2. So you see how we multiplicatively busted up the 20 as 4 times 5, but we separated the radicals because we want the perfect square portion in the front so we can evaluate it to get rid of the radicals. So that's really going to be 4 plus or minus 2 times the square root of 5 over 2. Do you see that? We're going to evaluate the square root of 4, and it becomes a 2. And then we're going to factor the top. Factor the top, and you'll get 2 times 2 plus or minus the square root of 5. And all of this is over 2. Now, do you believe that? Yeah, distribute that 2, and you'll see it's 4 plus or minus 2 times the square root of 5. Now we're ready to simplify by canceling the common factors. You only can cancel factors of the complete top and the complete bottom, so that's why we had to factor first. Now we can cancel, and we're left with 2 plus the square root of 5 together with 2 minus the square root of 5. Now here's the deal. I ran this through my calculator and found that the top, the one with the plus sign, is 4.2361, and the one with the minus sign is a negative 0.2361. Now, that dude's a problem. And why is he a problem? It's a bad solution because the number part. Now, think about this. This is the x value. And you go to the top, the very top of the problem, we had log base 2 of the number x. That means that this x value we're looking for plays the position of the number part, capital N, in the definition in note 115. But that note 115 says that the n part always has to be greater than 0. This x value would make our n part negative 0.2361. That's why we're throwing it away. We're only keeping the one solution, x equals positive 2 plus the square root of 5.